Our objective from this lesson is to define geometric series and find their sum. First of all, we have to define what is the geometric series. The geometric series is the sum of terms of geometric sequences. And we studied geometric sequences before. So, if I have a geometric sequence, starts with a sub 1, then the second term will be a sub 1 r, the second, the third, a sub 1 r squared, then a sub 1 r cubed, and so on till a sub 1 r in minus 1. To get the sum, we have a rule. This rule says S sub n equals a sub 1 multiplied by 1 minus r to exponent n over 1 minus r. Let's take an example. Example number 1 says, what is the sum of +3 plus 6 plus 12 plus 24 plus 10, 3070. Okay. Let's get back to the rule. We have S sub n equals a sub 1, 1 minus r to exponent n all over 1 minus r. What is the sum of 3? So I need what? From this rule, I need a sub 1, which represents the first term. So a sub 1 represents the first term. R represents the common ratio. And n, which represent number of terms. So this is what I need to substitute. Let's get a sub 1. A sub 1 here is 3. R, we can get it by dividing any successive terms. For example, 6 over 3, 12 over 6, 24 over 12, and so on. And all of this will give me 2. So R equals 2. Now I need to get n. Do I have n here? I know the first and I know the last, but I don't have the number missing terms here. So I cannot count to get the number. So I can use a sub n, the last term, which is a sub n. We will use the explicit formula. A sub n equals a sub 1 times r to exponent n minus 1. A sub n here, 3072. So 3072 will equal a sub 1 is 3 multiplied by r, which is 2, raised to n minus 1 power. As a normal equation, we divide by 3. And here also we divide by 3. Dividing this by 3 will give me 1024 equals 2 to exponent n minus 1. Here we have an exponential equation. So I need to make 1024 as a number with base 2. An exponent here would be 10. So, since the two bases are the same, so the two exponents are also the same. So n minus 1 will equal 10. So n will equal, move -1 to the other side, so it will be 11. Now I know n. Now I can substitute. So let's get back to our rule. S sub n here is 11, so I will put 11 equals a sub 1, which is 3, multiplied by 1 minus 2 to exponent n over 1 minus r, which is 2. And this would equal 6,141. Let's take another example. I need the summation of the sequence 4 half to exponent n when n, the lower limit, equals 0 and the upper limit is 20. Okay, I need a sub 1. So I will start substituting from 0, not from 1. So I will add here 1 to the upper limit. So n is equal to 21. A sub 1, I will start as we said with 0. So it will equal 4. And we have here half to exponent 0, which is equal to 4 times 1, because we know any number raised to 0, to the 0 power, it will equal 1. So a sub 1 here is equal to 4. And r is equal to half. Now we can substitute. S sub n, which is 21, is equal to a sub 1, which is 4, multiplied by 1 minus r, which is half, to exponent n, which is 21. All of this is divided by 1 minus r, which is half. By the calculator, you will find that the answer is approximately equals 8. Thank you very much. We explained geometric series. We defined the geometric series. We took the law that we can calculate the geometric series, and we took some examples to it. Thank you very much for listening. Till we meet next time, inshallah. Have a nice week.